Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2020 Test 7 Code C&D Physics. Let's move to question number 1. In question number 1, if velocity versus time graph of a particle moving along x-axis is given as shown in the figure, find the average speed of the particle from t equal to 0 to t equal to 5/2 second. So we know that the average speed is given by total distance divided by total time. So if I calculate the total distance, that is the area of this VT graph, so that can be written as total distance is half into base into height, that is the area of this segment, plus the area of this segment, plus half into, I have to calculate the total distance at t equal to 5/2. So at t equal to 5/2, the vertical coordinate will be 1/2. So I can write half into half. So this comes out to be 2 plus 1/8. So this comes out to be 17/8 meter. So the average speed can be written as total distance 17/8 divided by total time, that is 5/2. So on solving, it comes out to be 17/20 meter per second. So option 1 is the correct answer. Let's move to question number 2. In question number 2, a train has to move 100 meter from station A to station B in minimum possible time interval. If maximum possible acceleration of train is 2 meter per second square and maximum possible retardation of train is 4 meter per second square, then find the minimum possible time, assuming train is at rest at both stations A and B. So this is station A and this is station B, and the separation between them is 100 meter. In order to have minimum possible time interval, the train must accelerate with maximum acceleration and then decelerate with maximum retardation. So if I plot the graph of V versus T in this case, then from t equal to 0 to t1, it must have acceleration of 2 meter per second square, and then from t1 to t2, let this is t2, this must have maximum retardation of 4 meter per second square. So at t1, the velocity of the train must be 2t1, because initial velocity is 0, acceleration is 2, time is t1, so the velocity at time t1 is 2t1. So this 2t1 is equal to 4 into t2 minus t1, because for the second motion the final velocity is 0, initial velocity is 2t1, and the retardation is of 4 meter per second square, and the time interval is t2 minus t1. So this is equal to this, and we know that the total distance is 100 meter. So the area of this graph is equal to 100 meter. So I can write half into base, that is t2, into height, that is 2t1, must be equal to 100. So on solving question 1 and 2, I will get the value of t2, which is the minimum possible time. So that comes out to be 5 into root 6 second. So option 2 is the correct answer. Let's move to question number 3. In question number 3, a uniform ring of mass m, radius r is placed on a rough inclined plane having angle of inclination theta is equal to 30 degree. If ring is released from rest, then acceleration of topmost point just after the releasing is, assuming no sliding at the point of contact. So when there is no sliding at the point of contact, and let the angular acceleration of the ring about its center of mass is alpha, then we can say that the acceleration of topmost point is 2 times alpha into r. Now, in order to calculate the value of alpha, I am writing the equation of torque about the point of contact, because the torque due to mg cos theta normal and friction becomes 0 about this point. So the only torque comes is because of mg sin theta. So I am writing mg sin theta into r, that is equal to I about this point. So mr square plus mr square. So 2mr square into alpha. So if I calculate the value of alpha r, it comes out to be g sin theta by 2. So if I substitute the value of 2 alpha r here, it comes out to be g sine theta. So option 3 is the correct answer. Let's move to question number 4. In question number 4, a particle is thrown from the horizontal xy plane. Its velocity with respect to a moving person is observed to be 2 k cap meter per second. If velocity of moving person is 3 I cap minus 4 j cap meter per second, and acceleration due to gravity is 10 minus k cap meter per second square, then the radius of curvature of the path followed by the particle at t equal to 1 by 5 second will be. So at t equal to 1 by 5 second, if I calculate the velocity of particle with respect to ground, then its z component becomes 0. So it comes out 3 I cap minus 4 j cap. So at this moment, if I draw the xy plane, then let the x component of velocity is in this direction, that is 3 I cap, and minus 4 j cap is in this direction, and this component is 4. So if I take the resultant of these two, so the 5 will come in this direction, and the acceleration at this moment is acting perpendicular to the resultant velocity in this direction, that is g. So the radius of curvature at t equal to 1 by 5 second can be written as v square, that is 5 square divided by acceleration, and that is 10. So it comes out to be 2 by 5 meter. So option 3 is the correct answer. Let's move to question number 5. In question number 5, a swimmer at one bank wants to reach directly at point B dash as shown in the figure. If river flow speed is 5 meter per second, width of river is 4 meter, and BB dash is equal to 3 meter, then find minimum possible speed of swimmer with respect to river so that swimmer directly reaches to the point B dash. In order that the swimmer directly reaches to the point B dash, the resultant velocity of swimmer with respect to ground must be along this direction. So if this is the case, then I can say that the swimmer must swim in such direction, then it balances the component of velocity of river in this direction. So if suppose this angle is theta, then this angle is also theta. Then I can say that sine theta is equal to perpendicular, that is 3, hypotenuse is 5. So the value of theta comes out to be 37 degree. So if I take the component of velocity of river in this direction, this comes out to be 5 into cos 37 degree, so 4 by 5. So it comes out to be 4 meter per second. So if the swimmer swims in such a way that its velocity is in this direction, opposite to this component, and having a magnitude of 4 meter per second, then the resultant velocity of the swimmer is along B dash. So we can say that the velocity of swimmer with respect to river must be 4 meter per second. So option 4 is the correct answer.